let's see the original pole. Okay, the original pole, the original system. So you can see these two poles we have at -2 and -5. So how to draw the root locus on the real axis? We can just connect the first root locus to the next root locus to its left. So in this case, we have -2 and -5 only, so we can connect these two root locus together. So what we get is we get a root locus between two poles, -2 and -5. Okay. So next point is whenever you have root locus between two poles, there will always be a breakaway point. So in this case, is at -3 here. This is the point where the poles has multiple poles at the same location. So -3.5, -3.5. So when we add another pole at -1, what happens is the concept still the same. You have -1, you have -2, you have -5. So how to draw the root locus on the real axis? Connect the first pole or zero to the left of S-plane. So we have in this case three poles that is located -1, -2. So I connect -1 and -2, and then we have the third pole -5 here. So it will be alternate. There is root locus between two poles, and then next there will be no root locus between these two poles, and the next is there will a root locus from these poles to the left. And as I said before, when we have root locus between two poles, you will always have a breakaway point from these two poles. So you can see here these red poles and blue poles, and then will be one point where it will break away from the real axis to the j omega, sigma d plus j omega d. Let's say we add another pole. This time around I add at -10. So you can see here we have four poles. So we have at -1, -2, -5, -10. So how to draw root locus on the real axis? You connect for the first pole to the left. Okay, and then we have this root locus, and then we don't have any root locus between these two poles, and then we have another root locus between these two poles. You can see here we will always have breakaway point between two poles where we have the root locus. In this example, we have between -1 and -2, and another one is between -5 and -10. What will happen if I introduce zeros to the system? Now we have a system, third order system with no zeros. Okay, we only have three poles here. Let's say we add a real zero to the system. In this case, when we introduce 0 at -1, it is actually cancelled out with the real pole at -1. So you can see the behavior of the system is like the original one. So let's say we move the pole located at -3, for example. You can see here the pole on this imaginary axis bend to the left. It is opposite to what we have seen just now. When we introduce poles, the root locus will bend to the right. However, when we introduce 0 to the system, the root locus will bend to the left. So, see, I just drag it to the right. It bends more to the right. The closer it is to the poles, the dominant poles, it bends to the more to the left. But if I bring the 0 far from the dominant poles, it bends less to the left. So let's say I just want to put it at -10. You can see here, the effect of zeros is no more significant because it is actually like the original one. It bends to the right. So you can see when I drag the poles back closer to the dominant poles, the shape of the root locus, it wants to bend to the left. Okay, so when I put it on -5, it will cancel out the real pole at -5, and this is the shape of this root locus. Now we can see here from this root locus we have two poles. The root locus start from the poles where k is equals to 0. So it starts from this point, from this -2, from this -5. And then, since we have two poles, which is the beginning of the root locus, it must have two endings. Every beginning has its endings. So in this case, we have two poles where we have the beginning of the root locus at -2 and -5, and we will have ends of this root locus. It begins at poles, it ends at zeros. So in this case, we have no zeros, we only have two poles. That is why the root locus ending at infinity, one towards upwards, one towards downwards. Okay, so let's say we have three poles, so we have three endings, one at infinity, another one at infinity, and the third one also at infinity. Why? Because we do not have any zeros in this example. Okay, that is why we have three beginnings at -1, -2, -5. We have three endings at infinity, infinity, and infinity. If we have 0 in this example, let's say we have 0 at -10. So we have three beginnings at -1, -2, -5. We have three endings. The first ending is at -10 because from definition, root locus begins at poles, ends at zeros. But since we have three beginnings, we must have three endings, and another two endings is at infinity, infinity. Let's say I add another zeros, -8. Okay, this one is 10. Okay, so from this plot, you can see here we have three poles, two zeros. Okay, the poles is at -1, -2, -5, and we have zeros at -8 and -10. So you can see here, how do I plot the root locus on the real axis? The first one is connect whatever pole or zero of the first on the S-plane to the left. So we have this -1 and -2, we have root locus, and then alternate, we don't have any root locus, and then we have root locus between these poles, -5 and -8, 0, -8, and then we don't have any root locus, and then we have a root locus between -10 to the infinity. So we have three poles, two zeros, meaning that we have three beginnings at -1, -2, -5, and three endings. One is at -8, another one is at -10, and the third one at -infinity to the left. Okay, if you look at this, when we sketch the root locus, we can actually, from the location of poles and zero, we can actually just sketch it without we know the exact value of the poles. For example, in this case, I know that when we have a root locus between two poles, which is in -2 and -1 and -2, we know that there will be always a breakaway point. Remember? Okay, one will break away upwards and one will break away downwards. Okay? And then we know that the root locus must be between this -1 and -2, and then -5 and -10. So -5 already has its ending at -8. Sorry, this is -8. So these poles at -5 already has its ending at -8. What's left is these two poles, -1 and -2. We don't know where it will end, is it? Or we know? We should know because we already have another 0 at -10 and we have another one at infinity. So there will be always break-in point. This is the point we call it break-in point. Break-in point because the poles will always break in to find its ending. Where? At -10 and infinity. So from the vertical upwards, it will go to the break-in point, and then from this point also it will go to the break-in point, but we don't know which one go to the left, which one go to the right, but we know that these two poles will end at this -10 and another one at infinity. Okay, next let's see some properties of the root locus. Okay,